Hey guys, this is our last set of notes we're going to do for Unit 4B before our test. So we're going to be down here on slide 25 through 27 about comparing functions. So at the top of your paper, go ahead and put your title, Notes 4B.3.3, Compare Functions. So one thing that you will see, it's in the workbook, which we aren't doing that homework tonight, but you might see the word relative maximum or minimum. So when you're looking at a graph, I'm going to draw just like a little graph. This graph does not have a maximum or minimum because it goes up forever and it goes down forever. So there's no official maximum or minimum because the arrows just mean that they're going to keep going. What they do have is a relative maximum and a relative minimum for this problem. So a relative maximum is basically one of the turning points. If I only looked at this little interval right here, there would be a maximum. And then there's a relative minimum down here, basically your turning points. So it's just your maximum or minimum over an interval. So just kind of any one of our turning points would be a relative maximum or minimum. So today you're gonna be asked to compare functions. I think our problems are all either linear or quadratic are the two that you'll look at. And sometimes it'll be linear versus linear or quadratic versus quadratic, or it could be mixed kind of between the two. So the first one is if you are looking at a linear equation and you're asked to compare, more than likely the facts that you're gonna be asked to compare is going to be your slope and y-intercept. So they'll give you like two lines and they'll say, you know, compare the slopes and y-intercepts. And when you're comparing, you're usually just stating like which one's bigger, which one's smaller, are they the same? So when you're looking to find the slope, your slope is the letter m. So if you're looking at the equation y equals mx plus b, then your slope is just m. Or sometimes you have to find it as a point, like they might give you 2 points on the line, wherever it might be. But you can use the slope formula that y2 minus y1 over x2 minus x1. And then when you're trying to find your y-intercept, if it's an equation, y equals mx plus b, your y-intercept is just this part b. If it's in standard form or you're looking at your graph or something, you can just plug in x equals 0 and solve. And then you could be asked to compare quadratic functions. So with a quadratic function, they'll usually ask you to compare, they won't say slope, they're going to say rate of change. And a lot of times they'll ask you to compare the maximum or minimum values. So if they're asking you to compare the rate of change, then you're just going to use that same slope formula, y2 minus y1 over x2 minus x1. If they're asking you to compare the maximum or minimum values, then that's the vertex. The way that you find that kind of just depends. I mean, if it's graphed, you can just identify the point. But if it's in an equation, you got to look at which form it's in. So there's two types, or there's technically three types of forms that your quadratic could be in. The first one is if it's in vertex form, which is that like transformation that we looked at, the transformation of parent functions, was a parentheses x minus h squared plus k. Your vertex is just the point h comma k. Remember, h, you have to change the sign when you take it out of parentheses, but k gets to keep its sign. If it's in standard form, if it's ax squared plus bx plus c, then in order to find the vertex, it's negative b over 2a, and then to find the y value, you have to plug that in. And then you could be asked to find the y-intercept of, you know, this as well, and it would be the same kind of as I wrote above. You just plug in x equals 0 and solve. But those are the facts normally that they're going to ask you to find. All right, we're going to flip our paper over. We're going to do one example that I gave you, and then one example from the workbook. Okay, so go ahead and flip your page. Take a moment to pause and write down your example. All right, our example says, given f of x equals 2x minus 7 and g of x equals x squared plus 7x minus 7, compare the y-intercepts and rate of change over the interval 1, 3. Okay, so we're going to have to find the rate of change and the y-intercept, and we have two functions. So the first one is f of x. That one is 2x minus 7. That is just a linear equation. That's just a regular old linear equation. We can identify the rate of change. Rate of change for a line is just the slope, because it has the same rate of change across the whole thing. So the slope here is 2, and my y-intercept is -7. So there's no real solving or anything for that one. I have my slope is 2, my y-intercept is 7. My second equation is g of x, and it is x squared plus 5x minus 7. This is a quadratic equation. So in order to find my slope, I have to use my interval 1, 3. That's my x1, x2, because it's an interval, not a point. In order to find y1 and y2, I have to take these two values and plug them in. So if I plug in the number 1 squared plus 5 times 1 minus 7, I get 1 plus 5 minus 7, that is -1, so that's y1. And then I'm going to plug in 3. So I plug in 3 squared plus 5 times 3 minus 7. 3 squared is 9, plus 5 times 3 is 15, minus 7. 9 minus 7 is 2, and then 2 plus 15 is 17. So that's y2. So I'm going to plug them into my slope formula. I get 17 minus -1, because it's y2 minus y1 over x2 minus x1, so 3 minus 1. On top, when you subtract a negative, it turns to adding, so I get 18 divided by 3 minus 1 is 2, so my rate of change is 9. All right, now I need to find my y-intercept. So to find my y-intercept, you go ahead and you plug in 0 for your x. So I plug in 0 squared plus 5 times 0 minus 7. Well, 0 squared and 5 times 0, so 7 is just my y-intercept. -7, I'm sorry. Okay, so here's what we're going to compare. We're going to compare the y-intercepts. Okay, the y-intercept here is -7. The y-intercept here is -7. What do we say when we compare that? Well, we say that they are the same thing. Then we're going to compare the rate of change. So the rate of change for the line is slope, because the rate of change is the same throughout the whole thing. So the rate of change for that one is 2, but the rate of change for my quadratic is 9. So when we compare those, we're kind of basically just going to, like, they're not the same like they were with the y-intercept. So we usually just say which one is bigger. Okay, so we compare the y-intercepts. We're going to say f of x and g of x have the same y-intercept. -7, but remember, this one had the bigger rate of change. G of x has the greater rate of change. And it was 9 versus 2. So G of x had the greater rate of change. All right, so that's our example. We're going to put that on one of our slides. Now we're going to grab our workbook, and we're going to do one more example. So in our workbook, this is Unit 4B. And this is going to be on page 95. All right, so our example says two functions, f of x equals -2, x minus 5, x minus 5 squared plus 3, so this is quadratic because it's a power of 2, and g of x equals -4x squared plus 8x plus 3, that's also quadratic because it's a power of 2, each represent the volume of a rectangular solid. Which solid's function, f of x or g of x, has the greater max volume? So we're asked to find the maximum here. They're both quadratic, which means they're parabolas. So see how this a is negative and this a is negative? That means both of our parabolas are going to open upside down. So we're trying to find the vertex, which is our maximum value. So if it's a quadratic, then they have a maximum or minimum. It's a maximum or a minimum if it's a positive a, and it's a maximum if it's a negative a. All right, so the first one says determine the coordinates of the maximum point for f of x. So f of x is negative 2 parentheses x minus 5 squared plus 3. So again, it's a quadratic. This is in the form of vertex form where we have our h and our k. So it's all we have to use to find our vertex. Our vertex is h comma k. H, we have to remember when we take it out of the parentheses to change the sign, so it's positive 5. K gets to keep its sign, so it's just 3. So if it's in vertex form, and it's really easy to identify the vertex. That's why it's called vertex form. Determine the coordinates for the maximum for g of x. G of x is in what we call standard form, that ax squared plus bx plus c. So to find the vertex, you have to do a little bit more work. So to find our vertex, the first thing we need to find is negative b over 2a. So we have a, b, and c. So we're going to take negative, and then a is 8, over 2 times a, which is negative 4. I get negative 8 divided by negative 8, which is just 1. So that's the first part of our vertex. To find the second part of our vertex, what we do is we take the number and we plug it in. So once we find that number, we plug it in to our equation. So negative 4 times 1 squared plus 8 times 1 plus 3. So 1 squared is just 1, so that's just negative 4, plus 8 times 1 is just 8, plus 3. So 8 minus 4 is 4, and then 4 plus 3 is 7. So my vertex there is 1, 7. All right, so, oops, I didn't mean to erase so much. I was just going to change it to red. 1, 7. Okay, so now it says determine which of the function models has a greater max volume. So is it 5, 3 or is it 1, 7? So sometimes it helps us if we see it visually, because like 5's bigger, but 7's like the biggest number. So you have to kind of see which one it is. So we have the 0.5, 3, 1, 2, 3, 4, 5, right? And then up 1, 2, 3. So that is the point for f of x, maximum value, and then it just goes down, right? And then g of x is at 1, 7, so you go right 1 and then up 7. 3, 4, 5, 6, 7. And then that one just goes down. So when we're asking which one has the greater max volume, we're talking about which one is higher, has a greater y value. So even though this one's further to the right, this one is further up. So g of x has the greater max volume. So g of x has a greater max volume. And it's based off of the y value, 7 versus 3. All right, so on your homework tonight, it's delta math. You're going to be comparing functions, rate of change, y-intercepts, maximum, minimum values. You're going to put your notes in on slide 25 for like the notes part. The first example goes on slide 26, and then page 95 goes on slide 27, and that's it.